Okay, welcome back to the channel. Today for your troubleshooting and viewing pleasure, we have another K7000. This is the entire monitor out of the NBA Jam machine at the arcade. I've had this in the NBA Jam for, I don't know, probably 8 years or so. And it's been running flawlessly for 8 years with no problems. It already had new caps and rebuild and everything and replacement flyback. And you can see that it's been in the machine for quite a while. We got the dust and everything on here. And yeah, it's been working fine for the last 8 years, no problem. And then a couple of days ago, I get a message from one of the attendants in the arcade that says, hey, NBA Jam is all messed up. The screen the monitor's working. Let me see if I can actually show you a picture of what they had sent me. Let's see if it's... Okay, it's not there. Stand by. This is the amateur channel. I am not prepared, so hold on one moment. Okay, here is what the screen looked like. I immediately said, hey, turn it off. It looks like you've got some type of yoke. It looks like the yoke had shorted or some type of terrible yoke deflection problem. That's the picture they sent me. But that is not the problem. The problem, well, I should say that, I mean the yoke in the tube is not the problem. The problem is, I will turn this on here without any warning. I'm sure you probably understand what I'm about to show you here. Based off the thumbnail and title of the video, you already know what this is. But check it out here. 1, 2, 3. Lightning. Raiden wins. So, and this ran for who knows how long. It ran the whole time until somebody noticed it or heard it or figured out what was going on or happened to walk by and see, or someone said, hey, your NBA Jam monitor isn't working or something. So I have no idea how long this was running like this. And the fuse is not blown. So I have no idea how long that was happening. So I think for this video, what we're going to do is go through and show you what to check, what to look at, and how everything should operate and function, and what can be damaged by this exact problem. So let's get this off the tube and go over some things and see if we can get this up and running perfectly again. Okay, so you have a K7000 with a flyback that is arcing as we saw. What do you do? Well, the first thing is going to be to remove the flyback itself. Now, if you have a 7000 here that has all these remote wires kind of, no strain relief on the connectors here, I always recommend before you work on it, put a little zip tie through here. So while you're turning this over and back and forth, you put the strain relief on here and not on the actual connections, because you'll break the wires and not be enjoying yourself. So the first step here is we're going to have to remove the actual existing flyback. So we'll take that out and we'll desolder the G2 wire, which is on the back side of here, which is fine. So let's take this out and remove our flyback. Now, I'm not sure if I rebuilt this or who did it, because like I say, this has been in the machine for at least 8 years, because I had this NBA Jam cabinet for roughly a year or so prior to putting it in the arcade and opening up the arcade. We've been, this December, I think 16 days from now will be 7 years that we've been running the arcade. So this has been running for a little over 8 years with no problem. And I gotta say, 8 years of being on almost, well, yeah, every day for the most part. 8 years of being on at least 8 hours every day for almost 8 years. We got a pretty good run with this reproduction flyback, so I'm not gonna complain really whatsoever. I recently had to repair the monitor in our Double Dragon machine. The flyback that was in there was the original one and it failed. So I put a reproduction in there. It lasted exactly 1 day and failed internally. So I had to put another reproduction one in there, and that one's been okay for the last 4 or 5 days. So it's complete luck of the draw on these reproduction flybacks, whether you get one that lasts a day or whether you get one that lasts 8 years. It's just a complete random luck of the draw. And for those of you who don't know, while I'm doing this here, I'll go ahead and explain it. These flybacks are made at various different times of the year. So depending on when it's made, you'll have one that's going to be somewhat reliable, or you'll have one that's not reliable and might last you 1 day. The ones that are made in the winter time are the ones that are not necessarily very reliable. And the reason for that is that inside the flyback, you have a series of windings and a different, let me take this out and I'll try and explain it a bit better. There is several series of windings inside the flyback, and they're separated by a potting compound or a potting material. And that potting material has to set up properly, or what will happen is it'll break down and the flyback will start arcing internally between those windings, and it has to find a way to escape the high voltage. And the high voltage escapes out the side of the casing. Let's make sure this should come out of here. Now I got to do a little bit more work here. And that's why it arcs out of the side of the casing, because that high voltage that's shorted has to find some type of escape. And, same thing with the G07s that explode in half. I'm sure you've seen the G07 flybacks that literally crack around the middle and explode in 2 pieces. Same type of situation there. And there we have it. So let's get this out of here. There it is. So, holy crap, that was arcing for quite a while because there's a giant hole in the side of it. And if you ever suspect that the flyback has been arcing to the frame of the chassis, you can visually see evidence of that. If you look here, there's evidence right there. So if you have a 7000 here that you suspect the flyback is bad, but you don't see any actual physical evidence here, look on the side of the frame. You'll see there's no doubt. So that's one way to tell. But this is definitely one of the reproductions here, and there are a series of there's a winding here, a winding there, a winding there, a winding there, internally inside of here, and they're all separated by a potting compound that has to set up. And if you don't allow the potting compound to set up properly, then inside of here, the potting between the windings can break down and cause internal shorts, and that's how you get that voltage escaping out the side like that. So that's the reason this happens. Now, why does it fail on the ones that are made during the winter time versus the summer? Because the temperature is so much lower at the factory. Like these are made at a factory in China, and you can't rely on temperature constant. They may put the heating at 65 degrees in the factory versus 75 in the summer or whatever. But the reason this happens, and the reason these reproductions fail, is because during the winter time they don't allow the potting compound in here to set up properly, and that allows the internal windings to short out against each other, and you end up with this. So that's a very layman's way of explaining that, but if you ever wondered, that's why. So this is officially garbage. We're going to put it in the garbage can. So you've now removed your faulty flyback. What can be damaged? What do you want to inspect? Well, you have R91 and R92 in here. You have, let's grab the bristle brush and clean some of this off here. I think I did rebuild this because I'm the only one that really puts these the cross pattern on the tops of the caps. So obviously I did this like 8 years ago. But what can be damaged? So because the fuse is intact, we know our HOT and our voltage regulator is not shorted, but those can definitely get taken out. So if your fuse is blown, you got to suspect that HOT is bad, voltage regulator is bad, but in this case, that's good. So we know our C38's okay. We know our C37 and the diode that's behind it. I can never remember what that is, D15. So C37 and D15 should be good. But those are items you want to check. So we can go through and check all of our voltage rail and everything that we normally check. We'll go through and do that. But for the most part, when you have an arcing flyback like this, you're very suspectful of R92, R91, D13, and D14. Those are the most how do I phrase this? Those are the most common items to get damaged that you would suspect as being faulty. in a situation like that, because it's putting the high voltage directly to the frame, which is connected to these components in here. So we're going to check R91 and R92, D13 and D14 are the most commonly damaged items when the flyback is arcing to the frame. But what I find very odd is that our HOT and our voltage regulator should be okay because the fuse is intact. And if this thing was sitting here arcing to the frame for, you know, an hour or who knows how long before they discovered it, how in the world did these not get taken out? I don't have an answer for that. That's very odd. But we'll go to ohms here on the meter. Make sure your leads are good. Always check to make sure your leads are good prior to doing anything like this, because you'll go to read your resistor. Oh, the resistor's open. Well, no, the resistor's not open. Your leads aren't connected properly or something. But okay, we'll test R92 first. Should be about 1.2 ohms. You get 1 point. Well, I got bad connection here. 1.3. Okay, let's test R91, which is further back behind in here. And look at that. As suspected, R91 should read 1.2 ohms. So R92 and R91 should both read 1.2 ohms. R92, 1.3. R91, 167K. So, perfect example. Arcing flyback takes out one of those resistors almost every time. Now, what will the symptom be of R91 or R92 being out of spec? You will have vertical collapse. So we're going to have to change out R91. Now, what about D13 and D14? So we'll check D14 first, which is D13 actually. D13 is right here, 14 is further back. So let's check D13, negative towards the back of the chassis with the meter in diode mode. And we should get, you know, I think one of these I think is like 0.3. This one should be 0.47 or so. Ah, D13 is shorted. Dead short, 0 ohms. Yep, 0.3. Now what about D14, which we'll do right here. And D14 is not shorted, but I gotta flip my leads around, and it reads, okay, yeah, 0.5. Now in circuit, with the flyback, I should say, with the flyback installed, I think that reads closer to about 0.3 something. But with the flyback out, it's 0.45 as expected. So we have a shorted D13 and an out of tolerance R91. I bet you R91 is open actually. So now that we know that, let's go ahead and check the rest of our power circuit just as a refresher here for those who may be new to the channel. So we can do R103 should be 2.7 ohms. Oh, well, there's a good example of why you can't assume everything else is good. R103 is, oh, wait a minute. Hang on. Was I touching? Hang on. Now, I guess that makes sense. R103, if this was shorted, well, first of all, resistors don't short. Resistors open up or go out of tolerance. R103, it's not possible to have a shorted resistor, if you ever wondered that. I think I was touching the frame, so let's go ahead and just check on the bottom two pads here. Okay, 3 ohms. Good. Yeah, I must have been touching the frame or something, trying to poke through on down here. So R103 is good. Let's check our fuse is not blown, so we know everything is good. We'll check it anyway as a refresher. So we'll check our rectifier diodes D19, D20, D21, D22, D24, and D23. All good. Back to ohms. R104 should be 15 ohms. 15.7, a little high, but that's fine. R101 should be about 4.8 to 5K in circuit. 4.8K to 5K. There we go, 5K. And the reason it's supposed to be, it's a 6.5K ohm resistor, but it reads 0.5 because you're in circuit with other stuff and it's lowering the value. Also, if you go to test this and you read about 4.3 and it doesn't go any higher than 4.3, your HOT is likely shorted. So take that, if you will, as read. So that's okay now. R88 should be 1.8K. 1.7K, close enough. Yep. R89 should be 3.9K. 3.7, yeah, that's good. R96 should be 1.8. Yep, 1.8K. R97 should be 270 ohms, 270 ohms. 286, kind of high, but that's fine. R97, yeah. So that's all of our power rail there. We can check our C38 width cap, make sure that it doesn't read shorted, which it shouldn't, and that's right here. And yeah, 3 mega ohm, that's fine. And again, our C37 and D15 should read a diode here. Other way. There we go. Again, those are the little cap and the diode that's in there. Those can short quite easily, or C37 actually shorts quite easily. And let's check our HOT just to make sure it's okay. We'll leave it on diode mode, and yeah, 0.5 and 0.5. Our critical safety cap, you read diagonally like this from, this is all one shared pad, so you go negative here, and to this one should be 0.45. Well, 0.5 anyway. And then to this one, also 0.5. Let's test our voltage regulator. On the tall, skinny one, you go across pins 3 and 4. We should, 1, 2, 3, we should get about 0.15, exactly 0.15. So that should be okay. And the alternate way to test that is to go to your B plus resistor, go to ohms, and on a 25 inch, we should get 180 ohms and 179, so that's good. And that would, you know, kind of hold up because our fuse isn't blown. So it looks like the only thing we have to really worry about is R91 and D13. But the second thing we have to worry about, with those are directly part of our vertical deflection circuit. And if we look here, R91, which are these two pads here, directly connect to this pad right here. And that pad right there is this this blue wire here, which runs directly into the flux capacitor. No, it runs directly over to our vertical IC, as well as our vertical circuit here for our vertical size. But it runs directly over here to our vertical IC, which looks like pin 6. So we need to go through here on our vertical IC and verify that none of our pins read to ground that shouldn't. And if they do, it's very likely that it's due to our D13 being shorted over here. So we would need to remove R92 and our D13, and then if our IC still reads to ground on pins that it shouldn't, then our IC also got taken out. So I'm about 50-50 on the IC also being bad. So let's go ahead and just put our meter in continuity mode with our negative lead on ground. And let's go, here's a ground pin. Now we shouldn't have any other pins read to ground other than this ground pin. So there's ground. We have, that's pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, and pin 7. Okay, no other pins read to ground, so our IC is not shorted. However, we are getting an ohm reading on pin 6. It's in the mega ohm, that's fine, okay. So our vertical IC should be good. So let's go ahead and just remove R91. Did I say R92 a minute ago? I think I did. R91 and D13. Let's get those out of there and see if those are the only two causes of our problem. So we'll have to change these out, and then we'll also replace the flyback, and then we'll fire it up, and hopefully that's going to be our only issue. And if you're familiar with my videos on the 7000, you'll know that I always check 13, 14, R91, R92. I always check those anyway, because those can be problematic for vertical deflection. So now R91 is out. Let's remove D13, which is just behind it. It's dangerous to do what I'm doing here by using the tip of my soldering iron to kind of bend up the leg of the component, because you can damage the trace or the pad, but this is the amateur channel. So let's see if we can get D13 out of here. And yep, D13 is out. So now with those removed, let's test them out of circuit. And again, this resistor, R91, should read, well, I can tell you it's not going to read properly because it's all cracked and burned up, but it should be 1.2 ohms we get. Oh, it's open completely, as expected. Yeah, nothing. Here's our two leads, 0.2 on the resistor itself. Oh, wait a minute. Huh. Well, again, bad connection here. So these legs oxidize, and sometimes it's hard to get a good reading, but if we just press her down real hard, we get 250K. And if we look at the actual resistor here, it's a bit cracked here. It's a bit cracked along there and very discolored there. So yeah, that's no good for sure. Now let's test our diode and see if it's shorted out of circuit. And 0.4 ohms. So R91 and D13 definitely gone. So I'm going to kind of cut away here and steal those parts from another chassis, and then we'll come back and I'll get them installed in here, and then get a new Flyback installed, and hopefully that should be everything. So again, when you have this symptom of the Flyback arcing to the frame, you can almost guarantee yourself that you're going to have either a bad D13, D14, R91, or R92. And maybe, and also depends on how bad the situation is, on how robust your vertical deflection IC is, you could also have a damaged or bad vertical deflection IC. So that still remains to be seen. I can't tell you if that's good or not. All I can tell you is that it doesn't read shorted. So we'll change these two components, put the Flyback in there, and fire it up and see if we have deflection problems or not. Hopefully not, because it doesn't read shorted. And if we do, I've got replacements we can put in there, and we'll kind of go from there. But we also tested all of our power components, so our power should be okay. The other side of the coin is you could have a faulty IC1 or damaged IC1 or damaged IC2 as part of this as well. But I think we're going to get by here with just a bad R91 and D13. So let me get those sourced from a donor chassis, and we'll come back here, put this back together, and try it out, see what it does. Okay, so I got D13 and R91 successfully removed from a donor chassis, and we're going to go ahead and test them and get them installed here. So let's make sure that they read good before we go to the trouble of putting them in. R91 again should read 1.2 ohms, and if I get a decent connection on here, 1.4, that's close enough. D13, let's go ahead and put diode mode. We should get 0.45-ish voltage drop, 0.442, so those components are good. Let's go ahead and slave them in here. Well, not slave them in, I guess the technical term is stuff. Let's stuff them in the board. When you install all these passive components in a PCB, it's referred to as stuffing. So, but maybe technically speaking, it's only stuffing if you're putting all the components on a fresh board. I don't know, but the term for installing these components, these passive components on a PCB, is just called stuffing. And being that today is the day after Halloween, the day after Thanksgiving, I think that's probably an appropriate way to describe that. So that's installed. It's all installed the correct direction, the correct way. Let's get R91 in here if we can. Is it going to fight me or go in easy? I don't know. Sometimes you got to take this heatsink off to do this stuff a bit easier, but we have successfully stuffed R91 here. I say successfully, but I can't get this leg to go all the way through. Maybe if I press on it while I heat it up, that'll fit through there a bit easier. Yep, there we go. Okay, so that's through. Let's get that installed. Alright, now I'm going to go through here and hit up some other solder joints that looked a bit suspicious. And I didn't do this. When I rebuilt this for some reason, I never put the bridge across there. That's good. Let's do the same thing on this side of R101. There we go, that's good. That's good, that's good, that's good! And I think everything else is good. I didn't hit the thermistor for the decals. But R104, R89. Let's go ahead and hit that. Which you couldn't see, but right there is what I did. And I think that's going to be okay. Yeah, I had already done everything else previously, so. Now let's get a new flyback installed. I actually kind of want to inspect this a bit more. Oh, it's fine. Okay. Alright, well, I just placed an order for 7,000 flybacks here, and like I say, I already had to use one for that Double Dragon K7000 that lasted one day. And I don't hold it, I mean, I get all these from Peter at Arcade Parts and Repair, and I don't hold it against him because it's not his fault. You know, so like, if I install one of these that lasts one day, you know, you should be able to get one that's reliable for more than one day. But as I explained, it's not his fault. I mean, he doesn't make these. So if you get one that lasts one day, it's not his fault. So I don't really even contact him and say, hey, this flyback I got from you lasted one day. I want a new one. I don't even bother with that because it's not his fault, you know. And you can't guarantee these. And some of these will come with a screen pot that's all loose. The actual physical part here that you adjust is wobbly, and your voltage will change by just tapping this, and your screen will go bright, dim, bright, dim, bright, whatever, just by tapping this. And that's technically a faulty flyback as well. But in that case, it's still working, so I just kind of put it in place and then hot glue it and hold it there to prevent that from happening. So if you get one that does that, that's what I recommend. Just kind of adjust it to where it needs to be, throw some hot glue on there, and then as the hot glue is drying, hold it in place so it doesn't move, and then you can, you know, temper the rest of the adjustment with your brightness pot, if that makes any sense. So actually, I want to D18 here. We didn't test D18, and it often gets overlooked, but I know it's good because the flyback, I'm sorry, the flyback. I was looking at the flyback here. The fuse is good. So if you want to test D18, you can. And that's a diode here in front of the yoke connection. And negative is to our left in this situation. So let's go here, and yeah, it's good. So, all right, well, let's get this flyback installed. Then we'll do a little bit of cleanup. And hook it back up to the tube and give it a try. This damn camera is always bouncing all over the place, and I apologize about that, but and you don't need a whole crap ton of solder on these joints. People just they like to coat the ever-loving crap out of these joints. You don't need a bunch of solder. You just need a nice shiny little Hershey's Kiss. That's all you need. If it's a nice shiny Hershey's Kiss, that's a good solder joint. You don't need 1,000 tons and 1,000 pounds of solder on these joints. A nice dome that looks like a shiny Hershey's Kiss. And that's all we need. That's all we need. We don't need one other thing. So let's get a little denatured alcohol on here, a little toothbrush action, and hang on! I got rid of my towel and forgot to get a new one here. So let's just go ahead and coat that and start scrubbing here. This should clean up quite nicely. I like to use denatured over isopropyl because I think the denatured actually works a bit better and it cleans up and dries faster. I just like the denatured. I'm partial to the denatured as opposed to the isopropyl. But so there you go, nice and clean. And it could be a little bit cleaner, but that's fine. So, well, again, there we go. So. My mom used to correct me when I was a kid. I'd say so, and she'd say, what, sew buttons? As in S-E-W. So that's one thing I always remembered is I'd say so? So what? She'd go, what, sew buttons? I'd also say stuff like, I can't do that, I can't do that. She'd say, well, can't never did anything. Anybody else's mom out there ever say can't never did anything? Mine would always say that. But anyway. So, again, so what? Sew buttons? I'm trying to break that, as I mentioned in the last video, I'm trying to break that habit of always going so. Trying to break that habit, and it's not easy. It's like people that go all the time. It's not an easy thing to break. So, I just did it again. I can't get away from that. The Flyback has two wires coming off of it, other than the anode cup, of course. Never pay attention to the colors. So here's the old Flyback. You see this one has a white wire and a red wire. This one has two red wires. Disregard the color, never even pay attention, don't give it two thoughts. The thick wire is always your focus, always goes to your focus connection on the next socket. The thin wire always goes to your G2 connection. And in this case, I never removed the original pin, so I'm just going to heat up the pad here and pop the pin out. And then we'll stick the wire actually through the hole. Yes, this hard wires the neck board in place, but I don't care. It's once you're going to be doing, if you're taking the chassis out to fix something, you're going to be having the soldering iron on anyway. So there's no reason not to I just like to solder it in there as opposed to splicing and cutting and then splicing in the new connect, whatever. I just like to pop the pin out and just solder the wire in directly. Okay, now I also like to clean up all this wire mess here by kind of putting a zip tie here, because not only will that prevent the ground wire from breaking off the back of the neck board, but it just makes it look better when it's installed on the tube and all these wires all over the place. So you want to pay attention to your ground wire and not tie it in with the rest of it. Keep your ground wire out of the rest of it, and then you can just kind of zip tie all the rest of this stuff together just to make it look a bit better, more presentable. You don't have to do any of this, but it also helps the wires from bending back and forth. And the less strain you have on connections and joints, the better. So we're going to go ahead and just kind of put 3 zip ties on here to clean all this up. There we go. That's really all you need. You don't have to go overboard. Just 2 or 3, whatever you want to do, make it look nice. And there, that's much better. So, oh, there we go again. So, I'm never going to be able to kick that habit. Never, ever, not once. I'm going to say it every time. I've just been doing it for so long. Oh, I said it again, but that time I meant to. Suffice to say is one of the words the Knights of Ni cannot hear. Not is. You won't get very far in life without saying is. You said it again. No, I said it. Well, there we go. I think that's it. We got our 2 bad components replaced. Flyback is soldered in. We're all hooked up here. I think that is all that we need to do. I need to reconnect this, and I guess it's time to put this back on the tube, cross our fingers, and fire it up. Okay, we're back here on the tube. We have our anode, neck, yoke is hooked up. We have our ground connected. We have our power. We have our video and our remote board as well. So right now we're just worried about to see if it even turns on and powers up and doesn't arc immediately and all that stuff. And then also we have, if it does work, we'll spin it around here, and I have Mortal Kombat 2 here on the bench that will power up and give it a video signal. So we're hoping that it does turn on and work. We're also hoping that we don't have any kind of collapse or anything. So let's go ahead and fire it up and see what we get. 1, 2, 3. Okay. We had a little pop, but that was from inside the neck. Probably from all the issues we had when it was arcing to the frame. But the real question is, what does the image look like? And we have no image. That's because I forgot to turn up. These flybacks come from the factory with the screen pot turned all the way down. So I didn't turn that up before we tried this. Let's go ahead and verify here. Yeah, that was pretty much 98% turned down. Let's turn it up about 1/4. And yes, success. Okay, let's begin with, let's turn this around and go ahead and get the camera set up on the tripod. Well, it's on the tripod already, but let's go ahead and extend the thing here and open the feet up and set this down and see if we can make some adjustments here. Okay, now I'm sorry about the refresh rate. This camera is too cheap to lock in the refresh rate, but let's turn brightness all the way down, contrast all the way down, screen pot down until we lose the raster. Actually, let's do focus first so we can see. Right there. Now turn our screen pot down till the raster lines go away. Right about there. Nope, still there. Let's turn the light off so you can get a better idea here. There we go. Now, raster lines are still there. There we go. Okay, now, brightness up. I want to go to the menu for the game here so we can get a stagnant image. Alright, so we're in the menu. So brightness up until our background is not black anymore. Right about there. And brightness back down till the background is just black. Right about there. Turn our contrast up. Okay, that's pretty good. Brightness back down slightly. And now we'll have to readjust our focus a little bit. And that right there is not bad at all. Okay, a little too green I think, but let's go down here to our diagnostic tests, monitor patterns, crosshatch. Yeah, we're a little too green. But we'll take care of that here shortly. Let's do H position, roughly. So again, you see the red bars on the outside. You want those to be equidistant on the edges. That's good. And the vertical, roughly the same vertical size. We'll go roughly there with it. 50, 60 hertz pot is pretty good. I'd say that's not bad. We can start with that and see where we get. But we need to... Oh, I'm going the wrong way, okay. We need to turn the green down slightly. Green drive. That's a bit better. Okay, now let's escape out of here. Go down to here. Let's see what the image looks like. We should get a blue background for the Midway Presents. We don't. Okay, we need to turn our brightness up a little more. That's better. Yep, that's better. Okay. Vertical size is a bit too tall in the game here. Let's bring it down. Vertical position. Make sure it's good. Yep. So I was worried we would have collapse issues, but it seems like it's okay. Let's turn green cutoff up a little bit. Yeah, back down. Blue cutoff slightly down. And red up a little bit. A little bit more blue. What do you think of that? Yeah, so that Midway Presents, I said you should have the blue background. That's on a very, very, very healthy tube. For, you know, this has been running 8 years, almost 8 hours a day for 7 years. So given that, it still looks pretty, it looks much better in person, quite honestly. But it does need to be degaussed slightly, or degaussed slightly, however you want to refer to it. And regardless, I think that's pretty good. So yeah, I'm happy with that, at least for this repair. Looks pretty good. It looks a little bit more blue in camera. Maybe on the video it'll look a bit too blue, but you know, in person it's not bad. Not bad at all. Yeah, as I'm looking at the actual image in person, it looks really good. But through the viewfinder here, it looks a little bit off, but the camera never actually quite captures it the way that it should. But that's pretty good. That's pretty good right there. I can't argue with that at all, or complain about that at all. So, yeah. So if you don't know, on MK2, on revision 3.1, all you gotta do is just hold down, and they sit there and just punch forever. I forget what button's what here. There we go. Anyway, hey, there we go. Okay, I do have a little bit of tearing up here at the top. There's a little bit of screen tearing up here at the top of the image. Not sure why it's not focusing, but there you can see that little bit of tearing up here. I'm going to adjust the 50-60 Hertz pot, see if that gets rid of that, because that shouldn't be there. And not quite, but I'm not going to sweat it. Yeah, not going to sweat that too much. That's not a big deal. And probably depending on what game you're playing, you may not even notice it. So, yeah, it looks a little bit too green actually. Now that I took my eyes off it for a little bit, I need to turn the green down slightly. Yeah, I think that's pretty good. So we'll call it for now. And we had, what do we have here? We had a way out of tolerance R91. And we had a shorted D13. So when you have a flyback that's arcing to the frame, check those components I mentioned and went through, and this should get you fixed up. So thanks for watching. Hopefully you learned something. Make sure you like, share, and subscribe. Drop a comment down below if you want. And as always, stay tuned for more.